Welcome to the lecture on Umpolung. Umpolung is a German word which means a reversal of polarity. Usually, when an aldehyde is treated with a strong base like N-butyl lithium, the base does not remove the aldehydic hydrogen to generate an acyl anion like this. The carbonyl carbon negative charge is not developed on carbonyl carbon. When an aldehyde is treated with a strong base like N-butyl lithium, this N-butyl anion does not behave as a base to abstract the aldehydic hydrogen as proton. Instead, it behaves as a nucleophile and attacks at the carbonyl carbon to generate a tetrahedral species. And this happens when there is no alpha carbon containing alpha hydrogens. If there is an alpha carbon with alpha hydrogen present, then the same N-butyl anion will not behave as nucleophile. Instead, it will behave as a base and will remove the alpha hydrogen as H plus from here, generating enolizable carbanion. So, in case of an aldehyde without alpha hydrogen, N-butyl lithium does not behave as a base, it behaves as nucleophile, whereas a carbonyl compound with alpha hydrogen reacts with the N-butyl lithium, where N-butyl anion behaves as a base. From all our discussions, it is very clear that it is not possible to generate negative charge on a carbonyl carbon using a base. Usually, it is possible to generate positive charge on carbonyl carbon because if there is a positive charge on carbonyl carbon, it will involve in resonance using the lone pair of electrons present in the adjacent atom oxygen. So it is easy to generate positive charge on carbonyl carbon and not possible to generate negative charge. But we are going to adopt another method for introducing negative charge in the carbonyl carbon. So in this procedure, an aldehyde without alpha carbon having alpha hydrogens is treated with propane 1,3-dithiol in the presence of a Lewis acid to form 1,3-dithiene derivative. So if this group R is not there, it is called 1,3-dithiene and this is 1,3-dithiene derivative. When this 1,3-dithiene derivative is now treated with N-butyl lithium, now this base N-butyl anion behaves as a base and removes the hydrogen, the formyl hydrogen from this molecule. Therefore, the removal of proton from here results in the formation of the acyl anion equivalent. This is actually the carbonyl carbon where we could not generate negative charge, but after converting it into 1,3-dithiene derivative, it is possible to remove the proton from here to generate acyl anion equivalent. With this acyl anion equivalent, when we add an alkyl halide, this anion behaves like nucleophile, replacing the group X. Therefore, now this hydrogen which was originally present in aldehyde has been replaced by a new alkyl group. Now we can do acid catalyzed hydrolysis in the presence of mercuric chloride to regenerate the 1,3-propane dithiol along with the carbonyl group. Now the carbonyl group is connected to group R dash instead of hydrogen here. So aldehyde has been converted to a ketone. The conversion of an aldehyde into dithiocyclohexane, that is the 1,3-dithiene derivative, makes the carbonyl group protected. This is one of the techniques to protect the carbonyl group. So after the protection, the aldehydic hydrogen, the acidic nature of the aldehyde hydrogen increases. Therefore, when we add a base like n-butyl lithium, it removes this acidic hydrogen from here, resulting in the formation of a carbanion. This is actually the carbonyl carbon of our aldehyde, where we could not generate negative charge. Into that carbon we have introduced negative charge. So this carbanion behaves as nucleophile, reacts with an alkyl halide and gets alkylated. So after alkylation, we can remove the protection and regenerate the carbonyl group. Therefore, Umpolung means a reversal of polarity, which means in a carbonyl carbon, usually we can generate only positive charge and not negative charge. But into the very same carbonyl carbon, using this procedure, we are able to generate negative charge. This is what we call as reversal of polarity, which is mentioned by the German word Umpolung. Thank you for listening. Learn chemistry by solving problems. Thank you once again.